On behalf of the Lectureship Committee, I'd like to welcome you all to this lectureship tonight, this evening. This lecture series on the energy crisis is being presented under a grant from the S&H Foundation. And you might note that you were handed this slip of white paper as you were coming in, and we'd appreciate it if those of our off-campus guests would sign this card. And if you're not a visitor, we ask that you keep your card, and as questions come up in your mind, as Dr. Commoner is talking tonight, you might want to jot your questions down on this card, and then at the end of his lecture, we'll pass the cards to the end of the aisles, and then we'll have a question session. Following tonight's lecture and question period, there will be a President's reception in the Old Main Lounge. Everybody is invited to this. In the Old Main Lounge, you have to come in through the front of the Old Main building to get to the lounge. And I'd also like to refer you to your printed bulletins, where you'll note that tomorrow morning at 9:30, our guest speaker will be Dr. M. King Hubbert. Dr. Hubbert currently is working as a research geophysicist with the U.S. Geological Survey. He has been long recognized as an expert on the Earth's natural resources. Following Dr. Hubbert's lecture, at 11 o'clock, there will be an informal convocation featuring both Dr. Hubbert and Dr. Commoner. And to conclude our program, at 2:30 tomorrow afternoon, there will be a panel discussion featuring representatives from environmental groups, oil company representatives, and officials from the Iowa State government, and other prominent people dealing with the energy situation. And of course, you are all invited and encouraged to attend these too. Our speaker this evening has often been called, quite rightly, the Paul Revere of ecology. He is one of the earliest spokesmen for the safeguarding of man's natural environment from the effects of overpopulation and industrialization. He is also the author of the best-selling book, The Closing Circle, which won him both national prominence and the Phi Beta Kappa Award. He is currently serving as professor of plant physiology and director of the Center for the Biology of Natural Systems at Washington University in St. Louis. Ladies and gentlemen, will you please welcome Dr. Barry Commoner.
If they want to put the house lights on, that's all right. If they want to put the house lights on, that's all right. Sorry for all this delay with the technology. I'm really very glad to be here. I had those lights turned off because I couldn't see you, but there aren't any lights on, so I can't see you anyway. I'm really very glad to be here because in spite of the fact that according to the President, the energy crisis has been reduced from a crisis to a problem, and I imagine shortly to a footnote to the Watergate episode. It's a serious thing. It has a lot to tell us. We have a lot to learn from it, and I think that the people here at Drake are to be commended for having foreseen, because they've been working on this for a long time, foreseen the importance of taking a good, hard look at what the energy situation is about. And it's really going to be very interesting to see how the kinds of things that are on my mind fit or do not fit with the things that are on Dr. Hubbert's mind and what we say to each other tomorrow. That's a plug, so you'll come back tomorrow morning, because I think we're liable to have some fun. Actually, we disagree on some very fundamental things. Well, leaving that aside, let me tell you what I'd like to do tonight. Very wisely, the title that was suggested for me is What Price Energy? Because, after all, there's been a lot of trouble about energy, and it's got to be good for something. So it's really quite important that we ask ourselves, what are we going to all this trouble for? Do we really need it? What good do we get out of it? And so on. And it turns out that I am qualified to talk about that because the most effective way that we've got, strangely enough, to evaluate the meaning of energy to society is through an understanding of the environmental crisis. That turns out to be a very interesting and rather surprising relationship. And so the reason why I have found it possible to talk about energy, I'm no energy expert, I'm a biologist. The reason why I've gotten into it is that by learning what I have about the environmental crisis, I have been forced to begin to look at the way in which we relate to energy. And so what I want to do then is talk about the value, the social value, and the social costs of energy, because that's really what we have to decide. Let me remind you that energy is good for nothing by itself. I mean, just stop to ask yourself, what can you do with electricity directly? Not much. Really. You have to convert it into something. You can convert electricity into motion and move somewhere, or you can use it for making something. You can use it for generating heat and keeping you warm. But you've got to convert it. So that one of the things we have to look at is what social good can be derived from the expenditure of energy. That's on one side. But on the other hand, there are costs associated with it. For example, if you burn up oil and coal, the cost is going to be the loss of all the coal and oil, because eventually it'll all be used up. Every time you burn fuel of that sort, you pollute the air. So a social cost is going to be a certain amount of air pollution. And so the basic question that we've got is to balance a kind of triad. You think of it that way. There's energy in the middle, and on the one side you have to ask yourself, what good do we get out of it? And on the other hand, you have to ask yourself, what is the cost? And until you examine that whole relationship, you've really got no way of knowing why we're in this mess anyway. Now, as I said, it turns out that one of the effective ways to understand this relationship and the way in which it's changed in recent years is to look at the environmental crisis. And so let me talk about that first and show you why this is so. Let me give you an example of the way in which this turns up. It's sort of an exercise to get used to dealing with social costs and social benefits. You know, the environmental crisis sort of sprung on us around 1970. Suddenly everybody was talking about pollution and trash and how terrible it was, and there were too many people, and we were all too affluent, and so on, and there was something wrong in the way we lived, and it all burst out in Earth Week 1970, and people were presenting all kinds of theories about what that was all about. Now, I must say that I was terribly confused when Earth Week was over, because there were a series of different and contradictory explanations of what it was all about. There were people who said that the real problem was you and me. We caused the whole thing. We were the polluters. That goes back, in fact, to Pogo. Pogo said, we have met the enemy and he is us. And I went back and did a little research on Pogo's derivation of that idea, and it turns out that what Walt Kelly had in mind very clearly was an argument against people who were blaming the corporations. And there's a scene in, do you have Pogo around here? Oh, sure, the Tribune must. Right. There was a scene in the Fort Mudge dump in which somebody, like me, was complaining that it was really the corporations, and Pogo says, no, it's all of us. And so that was one idea, that we were all doing this thing. And then there were people, a number of biologists, who said the trouble was that, sure, we pollute, and the reason why we have all this pollution is that there are so many of us, that really it was a population problem. And there were lots of other things. And so I began to think about, what was the way in which we could understand this. And I decided that it would be a good idea to try to get numbers on this thing and to take a simple case where we could measure the way in which pollution has changed, the increase in pollution, find out when it happened, and what happened at the same time that might be connected with it. At the time, there was also a lot of discussion about affluence, increased affluence. We were supposed to be, we are, the most affluent country in the world, and maybe that was the cause of it. And so I did an experiment that I want to run through with you. It was just done in my head. And the experiment ran something along these lines. The first thing I did was to ask myself, well, okay, maybe Pogo is right and it's all my fault. And I began to re-examine my life in order to see how I was contributing to the pollution problem. And the first thing I had to do was to evaluate the problem, and it became pretty clear that it was a post-war problem. I'll give you a number of examples of this, but it turns out, and of course, as we'll see, this is very much related to the energy question, really the trouble all began after World War II. To put it very simply, if you could roll back the ecological clock to 1946, I don't think there would be any fuss over the environment. I don't think people were too unhappy about the state of the environment in 1946. If you flew across the country, you could see it, for example. Now you can't. You just see clouds of smog where there are cities underneath. And so that seemed like the period of time in which the change took place. And then I asked myself, all right, let's think of something in which you are more affluent than you were before and study it through and see how that's related to pollution. And I decided that one of the ways in which I had become more affluent since World War II, at the end of World War II, I'd just gotten out of the Navy, and I wasn't terribly affluent, and now I am much more affluent. And one of the measures of my affluence is that I now drink a bottle of beer with dinner every night, whereas before I didn't. And a lot of people do that. I said, fine, we will now take the bottle of beer and ask the question, what's this got to do with pollution? And right away you know that there is a big pollution problem having to do with beer bottles. For those of you who are younger than I am, you can do soda, okay? But same thing, soda bottles, beer bottles. And you then look and see, well, what is the problem? And it turns out there are statistics. For example, you can go to the U.S. Census of Manufacturers and discover how many beer bottles and soda bottles are manufactured each year. And the reason why they're manufactured is that they're used, and so you get a picture of how many bottles we've been afflicted with. And it turns out that the number of bottles beer bottles produced in the United States since 1946 has increased more than tenfold. And incidentally, that is a characteristic feature of the environmental crisis. 10 to 20 to 30-fold increases in the levels of trash and pollution. There are now 10 times more beer bottles around than there were in 1946. And no wonder people are complaining. And I haven't even mentioned the beer cans and so on, and that's one reason why they're strewn along the road. One of the laws of ecology is that everything has to go somewhere. And all those cans and beer bottles that are made, they have to go somewhere. And if they're 10 times more than they were, they're going to go everywhere 10 times more frequently. So there was the problem. And then I asked myself, all right, now you better explain how you have contributed to a tenfold rise in the beer bottles that are afflicting us. So I had to now face this issue that I've just described, the triad, because there's the beer bottle. I've already described to you, the bottle of beer, I've already described to you that it's got a social cost. It pollutes. Not only does it pollute because it's trash and you have to get rid of it and so on, but it also pollutes because to make a beer bottle takes energy. And there's the beginning of the connection that I'm going to talk about. It takes energy to melt the glass, make the bottle, and therefore the more bottles we use, the more energy is involved in delivering the beer. So the social cost of that bottle of beer is the trash and the energy use and the air pollution from the energy use and so on. Then I had to ask myself, well, okay, nobody produces beer bottles just to make trash. They're doing it for a purpose. What is the purpose? And I decided that the social value of the bottle of beer was the beer, not the bottle. That's a very interesting point. Very interesting point. You get a bottle of soda, and the same thing, you have to ask yourself, what are you after, the bottle or the soda? Okay? By and large, what you're after is what's inside of it. There are what we call second-order phenomena here. I know people who are very avid for beer bottles because they make nice glasses out of them by cutting them, and so on. But by and large, what you're after is what's in the bottle. And so now I've got something I can measure. I can now say that I will measure the social value of a bottle of beer by the consumption of beer. And I'll measure the social cost by the bottle. And right away you can ask the question, okay, is the country more affluent with respect to the social value? Now, the social value is not bottles of beer. It is the beer in the bottles. So you go back to the U.S. Census of Manufacturers and you look up the affluence figure on beer. And what is that? That is the consumption of beer, not bottles, per capita. And it turns out that's very easy to get because the Department of Commerce publishes the amount of beer produced in the country. We also know the number of people. And by dividing, this is a very crude measure, by dividing the number of the amount of beer sold by the number of people in the country, you can get a very crude measure of the per capita consumption of beer. And in 1946, it was 26 gallons per capita per year. And today, it is about 26 gallons per capita per year. No change in affluence. By the way, that's a lot of beer because my figure obviously includes babies. So someone's drinking a lot of beer. That's pretty clear. At any rate, there is no really significant change in the affluence of beer drinking. Is there a significant change in the per capita use of beer bottles? Yes. It's gone up tenfold. So that what's happened here is what? And incidentally, all this time, the population has gone up about 45, 47%. That's not enough to account for a tenfold increase in beer bottles. So really what this tells you is that the force that's driving this increase in beer bottles, in pollution, is not the increase in population, not an increase in beer drinking or affluence with respect to beer. It is a change, to be technical about it, in the technology whereby we deliver beer to the consumer. Because after all, if they were still drinking 26 gallons per capita in 1946 with 1/10 the number of bottles used, what was going on? How did they manage? Well, they used a very clever technique. It was known as recycling. Namely, the bottles were used over and over again. In fact, in 1946, the average beer bottle took 40 trips before it was destroyed or lost or broken. Now, you know what that means? That means that today, the ratio between cost and benefit, beer bottle to beer, is 1-to-1, right? 1946, it was 1/40th to 1. So right away, you can see, and we're using, for example, we now use a lot more energy per drink of beer. And you have to now raise the question, you know, we hear we are a terrible consumer of energy in this country. Well, with respect to converting energy into beer, we have been wasting that energy. We are now consuming a lot more energy and drinking the same amount of beer. So this was the experiment I went through, and I've now sort of explained really the whole thing to you. And let me now turn to some more serious things, because obviously we can't have our energy policy based solely on the drinking of beer or even soda. Let's take some serious things. Let's take something that Iowa is very much involved in, the production of food. The technology, and very often we hear that the environment is being polluted by agriculture in various ways. For example, we now have toxic pesticides and of various kinds in the environment, Practically none of them were used before 1946. There were really no organic chemical insecticides used at that time, no herbicides. You know that these things have caused biological problems, medical problems. Well, this is a change which has increased very sharply. We also use in this country 14 times more fertilizer each year, nitrogen fertilizer, than we did around World War II. And you know better than I that there has been a great change in the technology of food production in the United States. It's boasted about a great deal. This is what agribusiness is about, and so on. And so we now have to ask the question, in what way has this change, well, now let me go back to my beer analogy. What's a pesticide for? What is fertilizer for? What is anhydrous ammonia good for? There isn't a thing you can do with anhydrous ammonia until you convert it into something else. I don't know anybody who eats it or drinks it or rubs it on their skin or what have you. It's not a good idea anyway. But if you convert anhydrous ammonia, nitrogen, fertilizer, into food, that's a good thing. So what we've got then, and incidentally, nitrogen fertilizer is made out of natural gas. One of the reasons why the energy consumption in this country has gone up is that the fertilizer consumption has gone up. So we can ask ourselves this question: what is the triad that connects nitrogen fertilizer to the social value, which is food, to the social cost, which is the consumption of energy, and pollution? I can tell you something about the nitrogen pollution in Illinois because we studied it a great deal, and it's beginning to turn up in Iowa too. In Illinois, since the introduction of nitrogen fertilizer in the Corn Belt, the nitrate level in the rivers of the farm areas of Illinois has gone up tenfold. It used to be 1 part per million nitrogen. Now, every spring, in a number of the rivers, it's over 10 parts per million. Now, why is that a problem? Because nitrate is a poison. Nitrate taken into the intestine, particularly in infants, can be converted by bacteria to nitrite, another chemical form. That nitrite can cause medical problems. One thing it can do is to combine with the red blood cells and prevent them from carrying oxygen, and you can get a kind of blue baby disease. Another thing that nitrite will do will be to react chemically with constituents of the food, amines, and convert them into a chemical called nitrosamines, which are powerful cancer-producing agents. And there are a number of investigators who are studying the relationship between the increase in the nitrate intake in the diet and the incidence of cancer in people. And so there is a public health service limit for nitrate in drinking water, which is 10 parts per million nitrogen, and it is exceeded every year in a number of cities in central Illinois because they take their drinking water out of the rivers. And this has occurred only since the introduction of fertilizer, and I can tell you that as a result of our fairly complicated analyses, we now know that it is the fertilizer put on the cornfields which largely contributes to the elevated rise of nitrate. And so we've got a social cost. Water pollution due to fertilizer, a social benefit, the increase in food. Okay, what's happened to the ratio between the cost and the benefit since 1946, which is really when nitrogen fertilizer was introduced, began to be introduced in this country? Well, let me give you a figure. In 1946, the USDA has a common measure of food production, which is simply the USDA index. It's the most common way we have of equating the food content of different crops. So let's just take the USDA index as an arbitrary measure of food production. In 1946, for every USDA index of food produced, we used 11,000 pounds of nitrogen fertilizer. Today, we use over 55,000 pounds of nitrogen fertilizer to produce the same amount of food. Or you can turn it around the other way and say that the efficiency with which we convert nitrogen fertilizer into food has dropped by 80%. That is literally true. We now put that much more fertilizer into our agriculture per unit produced, and since another law of ecology is everything has to go somewhere, where do you suppose the extra fertilizer goes? Because you see, if you use a lot of fertilizer to make a crop, what that means is the crop isn't taking up all the fertilizer. And the result is it runs into the river where it pollutes it. And so there's a case, again, where we have changed the technology of food production, and as a result have reduced the efficiency with which energy is used. Energy means fertilizer. We now use much more energy to produce a unit amount of food than we did in 1946. So again, this is not an affluence question. Incidentally, food production per capita in the United States, measured in terms of calorie, has been essentially constant. In fact, in certain aspects, food production per capita has gone down since World War II. And those aspects are in the case of vitamin intake. The per capita vitamin intake in the United States, vitamin C, for example, well, that's not a good one because it goes up and down with fads. But certainly the B vitamins and a number of other vitamins, niacin, has gone down about 20% since World War II. The reason is a peculiar one. We had food rationing in World War II, and therefore, and also people tended to eat in restaurants and in institutional dining rooms. Well, the young people who sat at desks in Washington distributing the food used good nutritional tables. And when rationing was instituted, it was instituted in such a way that people tended to get good diets. And when rationing was taken off, then people bought food largely according to price. And vitamin-rich foods have gone up in price much more than vitamin-poor foods. And the result is that vitamin intake has gone down. Think of this. Until about 5 years ago, if you looked in the supermarket at fruit juices, say orange juice, cans, you'd find canned orange juice. Now go to the supermarket and try to find the canned orange juice, and you'll find 1 or 2 cans snuggled in among something called orange drink, right? And there must be many poor families who feed their kids a can of orange, whatever it is, used to be juice. It is now orange drink. What is orange drink? It is orange juice diluted at least 50% with water. And inevitably, the intake of orange juice has dropped. Well, what I'm saying then is that if you look at the food situation, something as important as that, you find that the increased environmental impact of food production is not due to an increase in population. It is not due to increased affluence with respect to food intake. It is due to a change in the technology of producing and marketing food. Namely, we use more environmentally stressful things like pesticides and herbicides. Let me ask you, I had a fascinating experience one day a couple of years ago in Washington with some moderately high official. We were talking about banning DDT. And he said, how can we ban DDT? We'll starve. The insects will take over. And I asked him, well, when was DDT introduced? He said, well, after World War II. I said, so what were the insects eating before? Well, okay. So detergents have a social cost. They pollute. Well, we have to ask ourselves, what is the social value of detergents? Social value of detergents is cleanliness. And that is widely regarded as a social value. You know that from the ads, if nothing else. People like to be clean. They like to have clean clothes. And so detergents are converted into social value in terms of the amount of cleaning that they do. Well, let me use a clean shirt as an index of cleanliness. It takes a certain amount of cleaner to wash a shirt, okay? Well, how did you wash a shirt in 1946? And again, I want to remind you, like DDT, people washed shirts in 1946. Well, they used soap.
The algae grow very rapidly.
Now,
and
you
when they
know,
grow rapidly, you get
our
thick
family
layers of
tries to
including
buy
the
soap to
so-called
use in the
algal
washing
blooms,
machine,
the green
and the
scum.
sad fact
And
is,
then
it
the
is
thick
now
layer,
literally
still algae down
impossible
at the bottom,
to buy
that's screened
pure
from the sun
soap
by
for
the
use
ones up
in a
above,
washing machine,
so they don't
unless
get
you want to
enough
buy ivory
sunlight to
soap
produce
and
enough
grind it up
oxygen,
yourself.
and at night
Ivory
it
snow is no
and
longer
dry,
pure
so
soap.
whenever you get a thick
They
layer of
added
algae
a
thickness,
whitener
they
to
die,
it.
they
You know what a
release
whitener
organic
is?
matter, which
A whitener is
cleans the
a
water.
synthetic
So phosphate
organic
is a pollutant.
chemical, which
The
is not a
phosphate
cleaner.
emitted into surface
It's
waters in the United
bears the
States
same
since World War
relationship
II has
to
gone up
soap as
sevenfold.
perfume bears
That
to
is the amount
cleanliness.
emitted every
What it
year.
is, it
There's
puts
been
a
big increase in phosphate
reflecting
output. Now, why
surface,
is
if
that?
you like, in the
Well,
clothes, so when
where does
light
it
hits
come
it,
from? Well, it
it
comes from
bounces
food
off,
systems.
and they
You can
look
check.
clean.
That's where the
You could
phosphate
take a
comes from.
dirty shirt and spray it
Well,
with
because
whitener, and it'll be
there are
dazzlingly
that many
white
more people,
and look
so that
clean.
much more sewage.
It also happens that
turns
whiteners
out that pounds
intensify the effect of agents that cause cancer. That's another fact. So, ivory soap, which is supposed to be a cleaner, now has whitener in it. Well, be that as it may, at any rate, 1946, we used soap. And we can now ask this question. For each shirt washed, how much phosphate went down the drain in 1946, and how much goes down the drain today? And the answer is, every time you wash a shirt today, 19 times more phosphate goes down the drain than it did in 1946. The reason is that 85% of the cleaner market has been taken over from soap by detergents. We've simply pushed soap off the market, and we use detergents. As a result, for the same, you see, and I don't care what the TV ads say, I don't think anybody's cleaner today than they were in 1946. I don't think the shirts are cleaner. I don't think people wash shirts more often. I think people, my experience, people are about as clean as they were. So what we now know is, for an equal affluence with respect to cleanliness, we have suffered a 19-fold increase in environmental impact. What about the energy question? That has become worse too. We now burn more energy to wash that shirt than we did before. Why? Well, let me explain it. First place, now we have to talk about soap and detergents chemically a little bit. Soap is made of fat, which is diddled a little bit chemically, and then it becomes soap. Fat is a longish molecule that has a series of carbon atoms attached, and it's a fact that when you string atoms together like that, you have to get energy to do it. It takes energy to hang them together. Where does the energy, where does the fat come from? Well, let's say typically it'll be cottonseed oil. Well, where does the cotton plant get the energy to make cottonseed oil? The answer is it gets it from the sun. The sun pours down on the leaves. The process of photosynthesis traps that energy, and by various chemical manipulations enables the energy to be used to hang the molecule of fat together. And the cotton plant does this then with a renewable source of energy. After all, the sun comes up every day. And on top of it, the cotton plant does it with no smog, no smoke, no fumes. Just does it very quietly, no noise either. Okay, so you can think of soap in these days, you know, everybody says how marvelous it would be if we could capture solar energy. Well, that's what the cotton plant does. It captures solar energy in the form of soap, of oil. Well, so we come along and say, well, we're going to displace soap with something that's called detergents. Okay, what's the energetic source of detergents? Well, in the first place, the cotton gets its carbon from carbon dioxide, which is in the air, to make the fat. And there's a fat-like molecule in detergents. Where does that come from? It's extracted from petroleum. So detergents use fossil fuel, a non-renewable resource. And besides, the energy that's used to put the thing together and react it is gotten by burning more petroleum, which pollutes the air. So that every time you you wash a shirt with detergent, it is costing us more energy than it did when you washed the shirt with soap. So again, one reason why the energy consumption in this country has gone up is that we have now been forced to use detergents instead of soap. And incidentally, did you decide to do that? No. Because I could assure you that if you decided, let's say, in 1947, you sat down and said, I want detergent, wouldn't have done you a damn bit of good. Because to make detergent, you have to own a factory. You have to own a very big factory. You have to be able to buy large amounts of petroleum and hire people and have capital and so on. The decision for us to move from soap to detergents was not made pogo-wise. It was not made by us. It was made by the people who run the factories. And I'll come back to that. So, again, here's a shift which has worsened our impact on the environment and worsened the utilization of energy. While I'm talking about synthetics, let me say the same thing is true in the shirt that you wash. In 1946, that shirt was probably made of cotton. Today, what's it made of? Well, it might be made of cotton, but it'll be darned expensive if you can find it. It's probably made out of a synthetic. Well, what is a synthetic? Well, what is cotton? Cotton is another one of these complicated molecules. The cotton plant makes it from carbon dioxide and water using the sun. The synthetic fiber is made out of petroleum, burning more petroleum to get the energy to do it. Now, here, I want to right away remind you that obviously the cotton plant takes some energy too, fossil energy, because the farmer needs gasoline for his tractor and so on. And we've done a computation on the total amount of energy that it takes to produce a pound of cotton and a pound of nylon. And when I say the total amount of energy, we've actually added up the energy that goes into the gasoline for the tractor, that goes into the fertilizer, the pesticides. We even added in the energy that the farmer uses for his telephone. Okay? The figure comes out for the present production of cotton and nylon in the United States that we use about twice as much energy to produce a pound of nylon as to produce a pound of cotton. And in fact, most of that energy could, in the case of cotton, could be done away with because the bulk of that energy is used to irrigate cotton fields in the Southwest, and in the Southeast you don't need irrigation, and the rest of it is used for chemicals, pesticides. So that these are all technological changes. So even with this input, cotton is a much more efficacious way of converting energy into a shirt on your back than the way in which we're doing it. Well, let me mention autos, because that's kind of an interesting thing right now. Well, okay, what is the social harm and what is the social good of an auto? Social harm you know about. Autos, well, they do an awful lot of damage. Smog is produced, it comes out of the back end of a car, literally. The highways require a lot of energy, and that pollutes the air too. Okay, what's the social value of a car? We'll be generous and say that it's to get from here to there, roughly speaking. So we have to ask ourselves the balance between the social cost and the passenger mile movement of cars. Well, let me give you a simple figure. In 1946, the average passenger car in the United States delivered 15 miles to the gallon. Okay, so that means if you sat in the car, by burning a gallon of gas and polluting the environment that much, and burning up a non-renewable resource that much, you would get 15 miles of movement out of it. Well, you know what the average mileage is today? It's well under 10 miles to the gallon. So the cars have been changed to reduce the relative social value that you get per unit social cost. The amount of lead put into the environment per mile traveled has gone up about 5 or 6-fold because now the gasoline has lead in it and before it didn't. And what's the reason? The reason is that the car engines have become more powerful than they were in 1946, and more important, the pressure, the compression ratio, the pressure in the cylinder has been raised. This raises the temperature. Raising the temperature is what causes smog, because the nitrogen and oxygen in the air inside the cylinder get so hot that it interacts to produce nitrogen oxide that gets out into the air, the sunlight hits it, makes it very reactive, it then reacts with the waste gasoline, and that's smog. I can tell you flatly that if we were all driving the same amount that we are today, and were driving Model A Fords, there would be no smog in the United States, because the Model A Ford engine ran so cool that it didn't produce nitrogen oxides. So the brilliant designs of the engineers in Detroit have transformed the automobile into a smog generator, into a lead producer, into a gasoline consumer. Okay. Let me mention finally the use of power itself, the use of energy itself. Electricity. Everyone says we have a terrific demand for electricity. The amount of electricity doubles every 10 years. Okay? What good is electricity? Interesting question. We have to now ask, how do we convert electricity into social value? And let me give you some numbers. We can take as a common social value, I'll now talk about it in terms, let's talk about it in terms of manufacturing. Manufacturing uses electricity, and it produces social value. How can we measure it? Well, a common value that economists use is what's called value added. That is, the value of the goods produced by a manufacturing concern minus the cost of the raw materials and the other things that are needed exclusive of labor. So value added is a way of measuring the increase in the economic content, if you like, of what is manufactured. You take a car factory and bring in glass and rubber and metal and so on, and out comes a car. Well, that car has value added. Value has been added to the raw materials to make the car. Well, let me give you some numbers now. For the average for all manufacturing in the United States in 1946, we got 70 cents of value added per kilowatt hour of electricity consumed. 70 cents. This same value, that is value added per kilowatt hour for manufacturing, is now under 45 cents. And I am using 1958 dollars. In other words, this is taking inflation into account. We literally use more electricity to produce the same economic value than we did in 1946. We are wasting electricity. Okay? Why? Well, different manufacturing techniques use more or less energy. So, for example, let me give you a contrast. In 1946, roughly, the clothing industry produced about $7 of value added per kilowatt hour. That was in 1946. Today, it is less than $2. In other words, it now uses much more electricity for the same output of goods. But at the same time, there are industries like the chemical industry which produce only about 20 cents of value added per kilowatt hour. Well, the chemical industry has grown much faster than the clothing industry. So, for example, the clothing industry has gone up, roughly at a rate at about the output of the clothing industry has gone up at a rate of about an annual increase of about 1.5% a year. The rate of increase, and that's a compound, the population goes up at about, it's about that per year. It oscillates, of course. So the clothing industry has more or less gone up with the population. The chemical industry, which is a very inefficient way of converting energy into social value, has gone up at the rate of 13% a year. A huge increase. And what's happened is that those industries that are least efficient in using energy to produce social value have grown at the expense of the others. And in fact, everything I've described to you is exactly that. Detergents, which are less efficient in using energy than soap, have pushed soap out of the market. Throwaway bottles, which are less efficient in delivering beer per unit energy, have pushed returnable bottles out of the market, right? Let me give you the most stark example. You know, right away you'll say, well, nylon or synthetic shirts are better than cotton shirts because you don't have to iron them. And that's true. That's true. So if I wanted to be very generous about it, I would say, well, for the sake of this increased use of energy and an increased impact on the environment, for the sake of having no iron shirts, we are tolerating a bigger impact on the environment and we're burning up more energy. And that's true. But there is an alternative. One alternative is to wear a cotton shirt and not iron it. And there are a number of them in this room. Right? Or let me tell you another alternative. See, we're a very fancy technological nation. Another alternative is to sit down and invent a way of weaving cotton that will not require ironing. It will remain flat without ironing. Brilliant. I've just invented seersucker. And in fact, you can buy one of the fancy ladies' shirt manufacturers makes a beautiful, very flat, sort of finely woven seersucker shirt, which I've been trying to buy in men's shirts, which doesn't need any ironing at all. It's just pure cotton. Okay? Of course, if I had more guts, I just wouldn't have the shirt ironed anyway, right? Or you wear a T-shirt. Well, the point I'm making here is that we have been pushed in the direction of meeting our social needs in ways which are very costly in terms of environmental impact and the consumption of energy. And so to go back to the title of my talk, What Price Energy? One of the things that I'm telling you is that the cost of using all this energy has been that we have transformed the way in which we meet our needs in a way that increases the degradation of the environment and burns up energy faster than it did before. And you might say that's enough, but there's something even more serious than that. And I want to tell you about that before I close. You know, it's not enough. See, I've just described what obviously sounds enormously stupid thing that the country has done. I mean, it all sounds idiotic. It really does, you know. Let me give you the prize idiocy, which is freight. I was saying in connection with cotton and synthetics, you can argue, well, you know, there's some advantage in the synthetics. Well, let's take freight. Now, let's say that you buy a refrigerator in Des Moines that's manufactured in Detroit. And you go to the store and buy the refrigerator. Now, to you, it won't make the particulate difference to you in the social value that you get out of the refrigerator, whether it was carried from Detroit to Des Moines in a truck or by rail. You wouldn't even know it. Okay. If it was delivered by truck, it would cost society 4 to 6 times more fuel than if it were delivered by railroad, because a ton-mile carried by truck uses about 4 to 6 times more fuel and pollutes the environment that much more than railroad freight. Yet, what has been happening? Truck freight has been increasing at 7% a year. Railroad freight has hardly been increasing at all. The railroads on the East Coast are bankrupt. And brilliant proposal emanating from our administration, a bill has been introduced to save the railroad by stripping off all the branch lines, which will force 20% of the freight onto trucks and increase the expenditure of energy for freight transport in the United States 3.5%, and pollute the environment that much more. So there's no argument there. This is a stupid thing to do, okay? But I don't think it's enough for me to stand up here and say, my, how dumb. And then everybody sort of beats themselves on the head and say we have to change our moral values. Our moral values are allowing the railroads to decay and we shouldn't use detergents and so on. Well, I don't know about your moral values, but my moral values have no influence over detergents or soap. Because as I said before, that's done in a corporate boardroom. And so we really have to ask ourselves the question, why was this stupid thing done? And it turns out that there's a very sound economic reason. And let me explain it to you. It's very simple. There have been a series of transformations. Detergents displace soap, plastics displace lumber, synthetics displace cotton and wool, trucks displace railroads, down the line. Each one of the new things that's been introduced is more profitable than the one that has been displaced. The numbers are perfectly available in government statistics. The easiest way to get at it is in the case of soap and detergents, because it's the same companies. And we know what the industry reports. The industry reported a 70% increase in the profit in making cleaner when they switched from soap to detergents. Why do you think they switched? To lose money? They're in business to maximize their profit, and it turned out to be a nice way to do it. I'll go down the line with you. Let's take beer, the throwaway bottles. A marvelous thing has happened in Oregon. Oregon is turning the history backward. Oregon has forbidden the use of throwaways. You know what happened? My favorite brewery, the Anheuser-Busch Brewery of St. Louis, lost 50% of its business in Oregon. Why? Because the Anheuser-Busch Brewery on the West Coast is in Los Angeles. And if they have to take empties from Oregon down to Los Angeles, they can't compete with a local Oregon brewery that just has to take it around the block. And what has happened in Oregon is that the big bottlers, not only the brewers, but the big distributors of Coke and so on, have lost money, and the local bottlers have taken it over. And there's been, now let me go back and explain why throwaways have been introduced. When I was a student, and you went into a small town in Iowa or New England or anywhere, you always saw a storefront Coke bottling plant. Any of you remember seeing those? Just a storefront. There was a little gizmo in there with the bottles going, and you'd stand in the window and watch the caps being put on. How many breweries have been closed down in the United States? Hundreds. And they were dotted in various places. See, what's happened is that big bottlers have taken over. Obviously, they don't want to ship empty bottles that long distance. So along comes somebody and says, well, let's throw the bottles away. And so they did. It was more profitable. Down the line, what about big cars and little cars? The cars, have gotten bigger, it's more powerful. Well, Henry Ford has put it very succinctly. He said, many cars make many profits. And what he meant by that is this, that per dollar invested in the manufacture of a cheap car that sells for $3,000 or less, the auto companies make less than they do on an expensive car. And one reason is that auto accessories are more profitable than autos, much more profitable. And a big car, you can hang more accessories on. And it's literally one reason why big cars are sold. You can't put big air conditioners on little cars and so on. Now, a very interesting thing is happening in Detroit. You see, they made a terrible mistake not being aware of the energy crisis that arose, and that we're going to talk about tomorrow. And as you know, about 100,000 auto workers are out of work right now. A number of auto plants are closed down because people won't buy the big cars. Well, do you know what Detroit is doing? There was in last Sunday's Times a series of articles about the shift. They are going to build small cars. Small, powerful, expensive cars. The car, you will not be able to buy from Ford or General Motors a car that costs less than $3,000. The little bitty things, the Vegas and so on, they're going to change the name and jack up the price. And what they're going to do is make American Mercedes-Benzes, really. See? Nice. It is a nice, small car, but expensive. Now, what does this mean? Well, you see, very interesting. When they said they were going to build small cars, I went back to my notes, and Emma Rothschild has written a very interesting book about the auto industry, in which she points out that a small car simply isn't profitable. And I said, my God, what's going to happen? How are they going to break even? And of course, they figured that one out. They simply are going to make expensive cars, and so that there's no problem about not selling them, they won't make cheap cars. You want a car, it's going to be expensive. Now, what does this mean? See, right away people say, well, let the economic system adjust itself to that. You know, you're passing the cost along to the consumer. Let me tell you what this means in a town like St. Louis. St. Louis is a town with zero mass transit. The buses that we have every now and then, they just run out of money and stop. It's an impossible sort of thing. And it's a town which has gone through the characteristic degradation of a city. When I moved to St. Louis 27 years ago, there was a large black population in the center of town, and in about 5 years, somebody got the legal right to do it, and they just bulldozed the whole place down, and for years, there was this whole area, and the black people who lived there were simply dispersed, and they had to find places to live. This led to a big pressure in the spread of the population. People fled, the whites fled from the city to the suburbs. You know, the whole thing. The center of the city becomes degraded until somebody can buy it up and build a ballpark. The center of our city is ballparks and convention centers now. Where people used to live, there are now ballparks. And this is the usual thing. So we grew like a mushroom, and the whites running faster than the blacks. So we have a ring of white suburbs, and then somewhat in closer are the blacks, and the blacks who can't even afford to move that far are still in the center of the city. Well, that's where people live. Where do they work? Well, the auto plants are out on the outskirts of town. And when a black breadwinner wakes up in the morning, he's got to go out to the Chrysler plant in the suburbs, most of them. There's no way to go except in a car. You have to have a car in order to work. And incidentally, the whites are out in the suburbs, and every morning the blacks wake up in one place and the whites in the other, and they drive this way. That's literally what happens in St. Louis. Now, some people say, see, that increases the mileage per capita. A very interesting figure, and therefore we're being more affluent. I looked up the figures on the mileage traveled by blacks in urban areas as compared with whites between where they live and where they work. It turns out that figure is available, strangely enough. It turns out that black workers travel 20% more than white workers between where they live and where they work. Is that because they're more affluent? No, it's because of racial discrimination. If you have trouble finding a decent place to live on the one hand and finding a decent place to work on the other hand, the chances are that two places will be far apart. I'm white and not discriminated against, and I'm affluent. I walk to work. I literally bought a house exactly the distance from the university, and I could afford it. Incidentally, in a suburb in which no black could live, because the real estate agents wouldn't do it, wouldn't even rent him a house if he could afford it. And one of the things I'm beginning to tell you is that, now incidentally, the situation in St. Louis contributes to the galloping consumption of gasoline in this country. If we had a decently organized city so that people could live within reasonable distance of a decent place to work in good housing, regardless of their color, people wouldn't be burning all that gasoline just to earn a living. And we would be having even more affluence and more well-being without burning that much gasoline. And so what I'm trying to show you is that the origin of all this problem has a great deal to do with economics and with social justice. Let me just finish with a few more of these economic items. What about railroads and trucks? Well, there's no argument. The railroads are going bankrupt. No one in his right mind invests in railroads now. In fact, the railroads won't invest in railroads. Do you know what the working capital of U.S. railroads until 1966 for years was $600 million. That's what they had around to spend to repair things and so on. They needed much more than that. It is now under $20 million in less than 10 years. You know what that means? They have taken the working capital out of the railroads. And what have they done with it? They haven't burned it. They've invested in real estate, in wineries, yes, in hotels, In airlines, the Penn Central, one of the brilliant things they did was to buy the Executive Airlines, which then went broke. Now, why do they do this? It's not what's known as diversification. They take the money out of a poor returning investment, the railroad, and put it in something that makes more money. So the railroads go down. You know, the rate of accidents on the railroads is now going up very fast because they don't maintain the tracks. So again, what I'm saying is that there has been an economic reason. And let me take this, the last point about the extra use of electricity. Why do you suppose it is that automation has taken place? Why do you suppose it is that the chemical industry is growing so much faster than the clothing industry or the food industry? Well, there is another form of looking at another way of looking at value added. Value added divided by electricity is going down. And that's what I like to call power productivity, the productivity of electricity. But the more common way of looking at productivity is what's called labor productivity, which is value added per man hour. And let me give you a figure.